Lesson 44, Regression Analysis. Example 3. Can the location of a person's belly button be accurately predicted based solely on their height? In order to investigate this issue statistically, a sample of 7 people had both their height and belly button height measured. This was accomplished by having the person standing straight and tall with their feet together and their head facing forward. While standing in this position, the person's height is measured from the floor to the top of their head. And while in this position, the belly button height is measured from the floor to the center of their belly button. The recorded heights are displayed in the following table, rounded to the nearest quarter of an inch. Conduct a linear regression analysis with this data to predict the location of a person's belly button based on their height. And, if it is appropriate to do so, use the linear regression model to predict the location of the belly button on a person who is 5 feet 6 inches tall. So first, we'll conduct a linear regression analysis. The linear regression model that will best predict y based on x is given by the formula y hat equals to a times x plus b, where a is the slope and b is the y-intercept. Now this linear regression analysis will be conducted to predict the location of a person's belly button. The variable in the linear regression model that is predicted is the y variable. So in this linear regression analysis, we are going to predict y, which equals to a person's belly button height. Now this prediction is going to be based on their height. And the variable in the linear regression model that we base the prediction on, called the predictor variable, is denoted by the letter x. So in this regression, we're going to base our prediction on x equal their height. So, if it is appropriate to do so, we will use the linear regression model to make a prediction. It is appropriate to use the linear regression model to make predictions when the coefficient of determination r squared is close to 1. Now, referring to the guide which indicates the steps we follow when conducting a regression analysis, we see that in order to use the TI-84 calculator to calculate the linear regression model, we first need to enter the predictor or x data into list 1. And then we need to enter the predicted data, the y variable, into list 2. In this example, we'll be predicting the location of a person's belly button. So in this case, the predicted variable y is the belly button height, and this will be entered into list 2. We are going to base this prediction on the person's height. So the predictor variable, x, is the person's height, and this will be entered into list 1. We could enter this data in the TI-84 calculator by pressing Stat, Enter to enter the list editor, and then we arrow up to the list names and press Clear, Enter to clear out the old data to make room for the new data. In list 1, we'll enter the person's height, starting with 66.25, 64.5, 70.0, 67.75, 74.25, 63.25, and 68.5. Enter. Then we arrow over to list 2, where we're going to enter the belly button height, starting with 40.25. Enter. 39.5. 42.75. 40.25. 44.0. 38.25. And finally, 41.5. Enter. Now that we've entered the x or predictor variable in list 1 and the predicted variable y in list 2, we can continue with the regression analysis. Now we could use the TI-84 calculator to calculate the linear regression model by executing the lin reg ax plus b command with list1, list2. To do this, we press stat, arrow over to calculate, arrow down and select linear regression ax plus b. Second 1 for list 1, second 2 for list 2. Press enter, and we've calculated the linear regression model. Here, the linear regression model that will best predict y based on x is y hat equals 0.522 times x plus 5.577, where a is the slope and b is the y-intercept. Now, in order to determine if it's appropriate to use the linear regression model to make predictions, we need to look at the coefficient of determination, or r squared. In this case, r squared rounds to 0.948. So, in interpreting these results, we can see that if we take x, the person's height, multiply it by the slope of 0.522, and then add 5.577, it will equal y hat, the best predicted location of their belly button. In this instance, it looks as if multiplying by 0.522 times the person's height, the location of the person's belly button is a little more than halfway up the body, plus the extra 5.577 inches. R squared of 0.948 tells us that about 94.8% of the variation in the location of a person's belly button is explained or determined by the total height of the person. So, with these results, we can make the following statements. The linear regression model that will best predict the location of a person's belly button based on their height is y hat equals 0.522 times x plus 5.577. And since the coefficient of determination, r squared equals 0.948, is very close to 1, the linear regression model fits this sample data very well. Hence, it would be appropriate to use this model to make a prediction. So now, we can use the linear regression model to predict the location of the belly button on a person who is 5 feet 6 inches tall. In this linear regression model, x, the person's height, will be 5 feet 6 inches tall. But this model was constructed using units of just inches, so we need to convert the 5 feet into inches. So a person who is 5 feet 6 inches tall is x equals 5 feet times the 12 inches per foot plus 6 inches, or a total of 66 inches tall. So we could plug this value of x into the model, and for x equals 66, we get a y hat equal to 0.522 times 66 plus 5.577, which calculates to about 40.03. Thus, for a person who is 5 feet 6 inches tall, or 66 inches, the location of their belly button is predicted to be about 40 inches from the floor when they're in a standing position.